This is the properties of matter for Chapter 10. We have talked about what matter is, that it is everything that has mass and takes up space. The first property that we have that all matter has in common, solids and your fluids, which consist of your liquids and your gases, is density. So we're going to continue on and look at the definition of density. Density describes how much mass is in a given volume of material. Now the mass is found by using a scale to figure out what the grams are. So you have water, which is 1 gram, aluminum 2.7, and steel 7.8. When it says a given volume, the given volume that we're referencing is this cube. It doesn't matter the amount of material that you are talking about to find the density. It could be 10 tons, 100 tons, 1,000 tons, but the density of the material that you're referencing, such as steel, is always going to be the same because you're only talking about this amount of the material of what its density is. The density of a material, of matter, is like its fingerprint. It is known specifically for it. If you have an unknown material, you can find the density by finding the mass and the volume and dividing. So density equals mass divided by volume. And you had a list, you can do process of elimination to figure out what your material is that you're referencing. Now looking at steel, you have 7.8 grams that can fit inside of this cube. Aluminum, you only have 2.7 that fits inside of that cube. That says something about the size of the molecules of these substances. If you can fit more grams of steel into that cube than looking at aluminum, that's telling you that steel is more compact, obviously meaning it's more dense, where aluminum's molecules are a little bit larger, take up more space, so less of them can fit into that same size cube that we're referencing of the given volume. Solids, liquids, and gases are matter. They all take up space, so they are all matter, so they all have density. Now you'll note that on this previous slide, we have water is 1 gram per cubic centimeter. Again, here, water is 1 gram per cubic centimeter. You're going to see this trend of giving the density of water over and over again throughout this PowerPoint, meaning that it is important for you to know what the density of water is. That is basically the main density that is used to compare to other things to see if they are going to sink or float. So when you look at steel at 7.8 here compared to the aluminum, the water, and the air, steel is the densest, whereas air is the least dense out of these. Okay. As we go through, we will look at all the comparisons of a variety of materials. And here you have a column that shows you different materials from highest density to the lowest density. Platinum being very dense. Now this is used for jewelry and things like that because it is dense and it does hold up and it's very strong. As you go down the chart, you'll see that as you go, aluminum is less dense. Glass, concrete, plastics too. Again, look, we have water listed again. Water is our main comparison. So if you would put anything that is listed above water in the water, because it's more dense, it will sink. So all of these will sink in water because they're a greater density of 1. Now your 1.2 may not sink all the way to the bottom because it's closer to 1. It may hover, and we call that basically like a neutral buoyancy because it's of a similar buoyancy to water. Now, ice is unique because ice is basically frozen water. Now, one of the things that we look at with the density of things is it will change due to temperature and pressure. You know that when things get hot, molecules speed up and take up more space. That means that they would become less dense, and vice versa. So if they got colder, the molecules slow down, they become more dense. But it is the opposite with ice. Water is an exception, does not follow the rule. Because of water's unique molecular makeup, it actually expands. Frozen water expands when frozen. So therefore, the density is less than 1. So anything that is less than 1 is going to float in water. So next time you put ice in a glass of water, notice the ice cubes float. So when you're looking at the densities of these materials, typically the units that you're going to see is for liquids, it is milliliters because you typically use a graduated cylinder to measure them. Solids are going to use cubic centimeters or meters cubed, depending on if the solid is a regular shape object. If it's an irregular shaped object, you would be finding the volume based on displacement, which then we would be using milliliters in that case. Again, here's another diagram that just shows you a range of common materials. Again, water, 1 gram per cubic centimeter. Going from a low density, from the foam, all the way around to steel being our highest density. Now notice, plastic is 2 grams per cubic centimeter of density, which is more than water, so you would typically think that plastic things are going to sink. But why does the bath toy float? This is the same reason a steel ship can float. It's about the design of the structure. Inside this duct and inside ships, when you look at the area, they have the hull, which is basically airspace. So airspace is one of the reasons that allow things that are more dense to float in something that is less dense. Also, due to displacement. In order for a steel ship to float, it has to have that airspace, but it also must displace as much water as what it weighs. So if you have a 10-ton ship, it has to displace 10 tons of water in order to float. So this will relate to surface area. Of a ship. And it's kind of like the same thing, like talk about the Titanic. The Titanic was a ship that had a big hull. Got a hole in it, and then it filled up with water. They said it was unsinkable because they figured with these little walls in the hull that if they got some water in it, it wouldn't fill up. Well, they didn't make them all the way to the top, so that water spilled over. And eventually the density of the boat became more than what it displaced, causing it to sink. Again, this is being redundant, repeating. Density is a property of material independent of quantity or shape. Independent, so has nothing to do with how much there is of it or the shape that it is of it. The density will always be the same. You can, of the material. So the object can change and be able to float or sink, but the density is not going to change at all. So here, if you look at a steel cube, the density is 7.8. You put it into the nail form, it's still 7.8. It's a smaller volume, but it's still the same amount of density. Liquids tend to be less dense than solids of the same material. Solder. Solder is a type of metal that's used to kind of like glue two metal pieces together. You find solder that comes into it, maybe like a metal stick, and then you heat it and it turns it into liquid. If you take 500 grams of solid solder, it only takes up the volume of 50 milliliters. Take that same mass of solder in the liquid form, and it takes up 52.6 milliliters. Because when a solid becomes a liquid, the molecules move apart because of the energy added to them. When they move apart, they take up more space, increasing the volume. So the density does change. Water is an exception to this rule, as we said before. Density of solid water is less than the density of liquid. So here again, we have our density of water shows up and our ice. And it will make sense when we talk in the next couple chapters about the molecular structure of water. To find the density of a material, you need to know the mass and the volume. Going back to the equation, mass and volume are the key things that you need to know. Mass is measured with the balance, and the volume can be used if it's a regular shape, length times width times height, or you use the displacement method. Now, the important thing with the displacement method is you look at the graduated cylinder and you put an initial amount of water. So this would be your initial amount. Once you put in your items, you look at your final amount and do the subtraction. The amount that is different is your volume. Now, when you read a graduated cylinder, you need to make sure that you read at the meniscus, which is the curved portion, bottom part of your liquid, to get an accurate reading. And you need to make sure that this is done at eye level. Density will change for different substances because atoms have different masses. Atoms may be packed tightly or loosely, and this goes back to my example of looking at the steel versus the aluminum. Here they give you the example of diamond. Diamond is one of the hardest things on the earth that's hard to break and that's made. Paraffin is a wax. You find this used to make candies and stuff like that. Those of you who have braces use it to kind of protect your mouth inside. Very flexible, so the density is very low, which allows it to be moldable. Okay. So due to the molecular shape will determine the density of it. To solve for density, given the properties of the mass and the volume, you can use the following equation. So D is density, M is mass, and V is volume. If you're asking to solve for density, you just plug in the mass and the volume and divide. But if they ask you to find for the volume, you divide mass by density. And mass then is density multiplied by volume. Another simple way is to use what we call a formula triangle. Here you have the same parts, mass, density, and volume. Now, if I take a question and I say, what is the density of an object? I cover up D, and it gives me the equation of mass divided by my volume. Oops, let's go back. If you want to find volume, you just cover up volume, and it gives you the equation of mass divided by density. Or you can cover up mass and solve for mass by multiplying density by volume. So the equation makes your life a little bit simpler to know what equation to use depending on what you're looking for, if it's density, volume, or mass. Again, this is just one of the properties of matter that we're going to talk about. But the key thing is solids and fluids, both liquids and gases, both share the property of density. You should have all these notes to reference for the lab that we will be doing following up on density.